Welcome to the HiRSE Summer of AI for RSE. If you want to learn more on how AI is changing the way we write and work with research software, this collection of episodes is for you.
Hello, I'm Dr. Jeremy Thompson. I'm a research software engineer here at the Helmholtz Centrum in Huron. I'm going to be giving a presentation today on the use of AI tooling in research software engineering. Specifically, I want to look at the considerations for the intersection between software development best practices and research ethics when it comes to usage of these LLM-based tools. Not all of the development best practices that are emerging in industry map easily onto research development processes that we see. So I'll discuss some of the considerations and challenges in that aspect, and also the introduction of research ethics into the software development sphere adds additional constraints that industry software developers do not have. These two things in conjunction mean that incorporation of LLMs into research software development needs to look different than the incorporation that we see in industry software development. Key takeaway from this whole presentation really should be that LLMs are not a magic bullet that fixes for us many of the challenges that we experience as research software engineers. One of the important things to note from this is that in this presentation, I am considering software as a first-class artifact. What I mean by this is that our research software itself, our repositories, our code bases, and their documentation should be treated as if they are research papers. So they should be presented in a way that is clear and contains attribution, all of the levels of review and clarity that we expect from research papers should be present in research software as well. This sort of perspective is informed by position statements such as the San Francisco Declaration on Research Assessment and organizations such as the Journal of Open Source Software. So we really need to take in consideration, if we're going to treat our research software like a first-class artifact, we need to treat it that way so that it is treated as a peer to those papers, and therefore we need to be very thoughtful in how we use our LLM-based tooling. So here's just a brief overview of the topics I'm going to cover. So at a high level, what we're seeing in industry is that these LLM-based coding tools are subject to the garbage in, garbage out principle. So we need to make sure that we're following best practices for input, having high quality code bases, good plans for how we're going to develop, and making sure that we scrutinize the review and output processes that we have in place to make sure that we're not just feeding garbage into these LLM tools and then just accepting the resulting garbage we get back out of these tools. So that means that there's considerations here around ensuring that our code bases maintain high quality so that the LLM output has a higher chance of being high quality, and that we're following best practices for previous human-based development, because a lot of those map well onto best practices for LLM-based development, at least in industry. At the end of the day, what this means is we still need high developer skill in order to ensure high quality LLM output, which is a known vulnerability for research software engineering. So one of the things I would like to call out as a caveat here is that high quality research on LLM best practices is proving to be somewhat tricky to identify. One of the reasons for this is because there's a massive amount of money in LLM research. So those profit motives there end up making the picture of the research and the conclusions we can draw from it somewhat muddied. Also, there's a tendency over the last several decades, research papers have moved towards including more positive and definitive wording. LLMs are actually prone to this consideration as well. That means that research papers are prone to present an overly rosy picture of the situation, which makes it difficult to gather a more pragmatic and balanced assessment of both advantages and drawbacks to a topic, in this case, LLM-based coding tools. So as a result, part of what I've done in building this presentation is include presentations from professional discussions I've had with industry software developers and reading various professional blogs. So one of the things that is important to consider when we look at the benefits that industry software development teams are seeing in some cases when they are incorporating LLM-based tooling and agentic AI into their software development practices is that in industry software development, these teams are governed by software development lifestyle principles. Now, there's lots of different ways to organize the software development lifecycle. So I don't want to focus on one specific model, but broadly speaking, software development lifecycle has three rough phases. There's the planning portion where the software team decides what needs to be coded and how that problem should be approached. So in this phase, it's decided exactly what will be an acceptable final product. Then there's the development phase where the code itself is actually generated. And then finally, there's a review phase that ensures that the code does meet the original planned objectives. So these industry best practices are built upon the some sort of an SDLC process. However, academic software development very frequently doesn't incorporate SDLC practices or principles. Specifically, the planning phase very often is commingled with the development phase, which can make it very difficult to ensure that the LLM-generated output is meeting original plans if the planning and development are commingled. The industry software development teams are actually saying that these LLM code generation tools are moving more effort into their planning phase to ensure that they know what output they want from the LLM, and the review phase to ensure that the LLM generated output does adequately meet those needs. So in order to get the sort of benefit that we're expecting to see if we compare academic software development to industry software development, we really need separate planning and review if we hope to see their same benefits. So what that really means for us is that we need to make sure we decide before we start code generation, what code do we need to generate? What do we expect the behavior to be before we start prompting for code? The LLM then comes in most beneficial if we're looking in the development phase. The LLM can help us write that software faster. But we ultimately are the ones deciding if that generated code is correct. So we need a strong review phase to ensure that the correct code was generated, subtle flaws were not introduced, the exact requirements are indeed being met. One area that perhaps could be beneficial to research software engineers who are looking at incorporating LLM-based tools or agentic AI into their development practices is to look at test-driven design, where first the outcomes are clearly identified and constructed as a series of tests that must pass before the code is accepted. One thing it's interesting to note is inside the development phase, we can actually break down these software tests that we're attempting to complete into smaller loops, so smaller subtasks, and then we can use this same pattern of plan, develop, review as we're generating small pieces of this code and composing. And the smaller our loop is on that phase, the easier it is for us to control risk and to review the output. The larger the amount of content that's being reviewed all at once, the easier it is to have mistakes or poor output from the LLM go unnoticed and then move into our code bases. So one of the things that is noticed not just from a process point of view, but from an initial code base point of view, is that the actual quality of the code base matters when we're looking at output quality from the LLM, which makes sense. In some sense, these LLMs are just replicating the existing patterns they're looking at. So if you have a well-structured code base that has a lot of patterns that you want to see the LLM replicate, that is easier for these agentic AI and LLM-based tools to replicate good code if you have lots of examples of good code. Specifically, there's been some research with a quality metric called code health. As I noted before, this is an example of profits sort of coloring the research. The research papers I found on this were specifically by the development team for this paid software suite, but it sort of matches the discussions I had with industry software developers, where the better their code base looked, the more likely the LLM was to replicate good code quality. And specifically, the code scene team was arguing that if their code health metrics were higher, that meant that LLMs that were given refactoring tasks, the resulting output from the LLMs, the refactored code, was less likely to fail the existing test suites. Which this is a sort of a touch point that indicates to us that high quality code bases that have sound code with a lot of good structure in it are better candidates for feeding into LLMs and giving us better quality LLM output. One of the other things that I encountered when I was having discussions with other professional developers from industry is really you need a high amount of developer skill, really in the planning phase and also in the monitoring the LLM output, fixing errors that the LLM may introduce. For instance, you need frequently someone in the review process of the LLM output to know common mistakes or common issues, perhaps specific to the code base or specific to a language. One thing to keep in mind as we're using these LLM-based tools is that they are trained on a large pool of publicly available software, and that publicly available software contains common errors. Therefore, these LLM tools will generate those common errors as part of their output because it's in their training data. So we, as the research software engineers, need to be aware of the common problems so we can detect it in the output and eliminate it so that those common errors do not become incorporated into our code bases. Also, Style consistency is one of those things that you can direct the LLMs to mirror style consistency from the code base, but these LLMs are not perfectly going to follow instructions that they're given. It's not like you're providing exact instructions the way that you would with other pieces of software tools that can meet exact constraints. It's more of a loose or fuzzy adherence to these instructions that you're providing as input into these LLMs. Therefore, we need to make sure that the output does in fact meet the targets that we are providing as input. At the end of the day, one of the messages I want to keep emphasizing in this presentation really is that high developer skill is required for us to ensure high quality output. And specifically why I want to call this out is that research software engineering organizations are listing skills and training very commonly as a weakness inside the research software engineering career field and in our communities. So if we're having difficulty ensuring that we have adequate training and support, that means that we need to be very thoughtful about our LLM usage, since industry software developers are noting that high skill is required for high quality output. That means that we have a potential vulnerability here where we may, if we have limited or missing skills in certain areas, we need to be aware of that, because that means that we have a degraded ability to detect low quality output in those areas where we do not have adequate skills. One of the things that's also unfortunate that we're noticing is that LLM usage can actually inhibit skill formation. So we need to be thoughtful about how we're using these LLM-based tools to ensure that we are still improving our skills as research software engineers. Specifically, it's one of these things where there's interesting papers about skill erosion or inhibited skill formation, where the LLMs interrupt the cognition that we're doing. So it's so easy to generate output without a lot of dedicated focus from the research software engineer. That's what allows these tools to generate code quickly, but it also is the exact same mechanism that ends up degrading our skill formation and our skill retention. So since this de-skilling and this inhibited skill formation is a known risk with LLM usage, and research software engineers have a known issue where we do not always have as many skills as we would ideally like to have in order to ensure high quality software. This is a particular risk that we all need to be cognizant of. And if we touch back to this theme that research software really needs to be a first-class artifact like a research paper, we need to be ensuring clarity and correctness in the output, the generated code base. So we need to make sure that we are retaining the skills that allow us to ensure high-quality software. So this is a complicated risk for us if we look at the known state of research software engineering and the fact that we're attempting to build software that people can look at as if it was a research paper in order to draw conclusions from the software and understand how the users and the developers are using this software in our research processes. So just as a quick summary point here, looking back at what industry has seen, we really need development best practices training in order to ensure that we are using those LLMs correctly, and so that we can see the sort of benefits potentially that industry software development teams are experiencing. But skills and training is a known weakness in research software engineering, and LLM usage can result in de-skilling or inhibit skill formation. So we've set up a particular set of weaknesses here that specifically are more acute in research software engineering than industry software engineering, and we need to be aware of these weaknesses as we move forward with these tools as research software engineers. Really, the bottom line is that we need to ensure that we have good development skills before using an LLM, and then that we retain those skills as we're using these LLMs, especially as we're looking to ensure that we have good clarity and correctness in our paper, in our software, if we're going to treat them as papers. One area that I particularly want to call out that is a common area of use for LLMs in industry software development is code review. Now, code review is a high skill activity. As I mentioned before, it helps to have developers in the code review process who are very familiar with the languages involved and the code bases involved to know common issues, expected patterns, that sort of thing. So we need to be careful because there is a de-skilling risk or a skill formation degradation risk present also in code review. But this is one area where LLMs have shown to have some interesting applications is in this code review process. As an aside, one thing to note, though, is that LLM-based code review appears to consume a very large number of tokens, which makes sense. A large amount of code needs to be consumed, not just the changes, but the surrounding context in order to have effective LLM-based code review. As token costs rise, we need to be aware of this risk. So while LLM-based code review is a promising application, it may help us improve the quality of our code bases. There's also a risk that it may become unaffordable for some researchers. There's a lot of tools out there, like CodeRabbit, Copilot, Cursor, Claude Code. There's a lot of these tools out there, and a lot of them offer different advantages and drawbacks. So it's one of those things where individual research projects really should consider the different options available to them if they're investigating LLM-based code review tools. One of the things that's also a consideration for non-US based research teams is that there's concerns, particularly emerging among European research teams, that we don't want to be exclusively beholden to large US tech companies, but a lot of the models backing these LLM-based coding tools and these LLM-based code review tools are all controlled by US tech companies. One emerging possibility for an alternative is so-called small language models. It's running very frequently open weight models on local hardware, so you have more control. You have 100% control over your data, and privacy issues, and you're not paying in order to access a proprietary API. On the other hand, you do have drawbacks around these tools are less capable of processing large context windows. Therefore, they are not as able to handle code complexity as you see with these large language models. Now I want to move and consider not just industry practices, but also how these tools intersect with research ethics. So research, as a broad statement, research requires transparency in our methods and in the tools that we're using. And it requires citations so that we have a clear understanding of this chain of ideas, of where different ideas connect and who we got our ideas from. So if we look at these codes of conduct for research integrity, we see very common themes that we need to be aware of when we're using these LLMs, especially if we're going to consider our software as first-class artifacts. We need to hold that software to the same standards that we would expect when we're authoring research papers. So one of the common themes that we're seeing in these codes of conduct around using LLM tooling in research and in research software development is we need to disclose what tools we're using, which is a very natural requirement. Disclosure is really how we do science. That's why we publish our papers, is to disclose what we're doing and to justify the conclusions that we're reaching. And the same thing here with our software development. Our software is a research artifact, so we need to disclose how we're generating this software. One of the nice benefits with this disclosure is not just in terms of reproducibility, but also it allows us to curate a common understanding of successful ways to incorporate these tools into the generation of research software, and it allows us to discuss unsuccessful ways to incorporate these tools. Really, when it comes down to it, I would say that if we feel uncomfortable disclosing that something that we're doing, that is an indication that that technique is not ready to be actually released and shared broadly, and we really need to improve that result, improve that output, and so that it's in such a form that we feel comfortable disclosing what we're doing. If we feel like something shouldn't be disclosed, then that means that something is wrong, something's not ready. So really, disclosure is a natural requirement that's emerging in a lot of the common codes of conduct that we're establishing in these different research communities. One thing that's quite nice is these disclosure policies are aligning quite well with open source policies. Very often, research software development intersects with, overlaps with open source because many of our research software projects are released as open source software. And if you look at the open source software development communities and these projects out there, many of them are developing LLM policies. And if the projects do permit community members and developers to submit LLM output, be it code or documentation, what have you, disclosure is pretty much a requirement in all of these community policies that we're seeing. This makes a sense in particular because code review processes can be improved when you disclose that you're using LLM tools and which LLM tools you're using. There are certain types of known issues based upon the LLM-based tool that we can look for when we're doing code review. As an example that I've seen is that LLM-based tooling tends to provide more local change sets rather than a more broad, overarching solution, even though perhaps a more broad solution might be more simple and elegant and a better way to provide a fix to a problem or to implement a feature. These LLM generated changes often are much more small, so it can miss opportunities to make these sort of broad changes that allow us to reduce repeated code and just sort of overall have better consistency in our code bases. So these sorts of common LLM-based issues can be looked for if the submitting developer discloses that they are using LLM-based tools when they make their pull request or their merge request to the repository. There is a big list here that I found of open source software development project policies specifically discussing LLM usage. Another consideration that we have as academics that's not as strongly present in industry software development is this consideration around plagiarism. So one famous example we have is Dr. Tim Davis was able to prompt Copilot to generate copyrighted components of the C-sparse code suite, and this code was generated without attribution, and that would be a licensing violation, but it would more importantly be a plagiarism issue. So it's possible for us researchers, when we're requesting a very large amount of code to be generated all at once by an LLM, it's possible for us to have in the generated output novel algorithms or components that are almost verbatim from other people's code bases. And if we did that in a research paper, we would consider that to be plagiarism. It should be the exact same thing in research software development. If we're going to treat our code bases as first-class artifacts, if we're implementing novel algorithms from other researchers, then we should be attributing those researchers somewhere in the code base, in the documentation. And if we just prompt the LLM for a large quantity of code all at once, then we can miss that attribution opportunity, and then we have just accidentally plagiarized the work of other researchers, therefore violating research ethics. So we need to be aware of these ethics considerations. So ultimately, it is us, the research software engineers, who are responsible for the code that we're submitting to our research projects. Therefore, it is our ethics that we need to keep in mind. It is our reputation and our behavior as researchers that we're responsible for. So we need to ensure that when we submit LLM-generated content, that content is in fact not creating an accidental plagiarism concern. One of the things that we also need to be aware of is that these LLMs can generate citations for us. However, the citations can be completely fabricated in some cases, such as just completely citing research that was never actually published, or the generated citation may contain errors. The dates are wrong, the journal is wrong, the paper title is wrong, something of that nature. So we need to make sure that we're not generating flawed or fabricated citations, as that also presents a ethics consideration for us. There's also the fact that the LLM output can miss a portion of its training data that's relevant to the input prompt when the citation is requested to be generated. So we might be omitting relative citations. Really, we need to sort of keep this in mind is if we're asking for LLMs to generate, or if we're using LLMs to generate output and then generating citations after the fact, we have inverted the usual research process. Typically, you do research looking at what the existing research out there is, extending that, reaching your own conclusions, and citing the original research that inspired you. However, if we flip that around, we have sort of destroyed the integrity of the research process, where we first decide conclusions that we would like to argue and then go hunt for possible research to justify our preconceived conclusions. So we need to be really careful when we're using LLMs to generate citations so we're not inverting this research process and first reaching a conclusion and then finding some sort of a justification for our conclusions. One important thing to note is that LLM-generated citations reinforce the existing bias that we're seeing. The most commonly generated citations are going to be the most commonly cited sources. So we may miss important contributions from less known researchers. Researchers who are women, who are people of color, who are from researchers who are from regions who are underrepresented in journals or in conferences. So we need to be aware of these biases and make sure that we're really citing the true origin of the inspiring research that we're using to base our further work on, rather than just reinforcing these existing biases. So when it comes to research ethics and summary, I would say that it's easy for us to accidentally plagiarize, particularly if we're using LLMs to generate large amounts of output all at once. And if we're using these LLMs to generate citations, that citation could be fabricated, flawed, or injecting bias or reinforcing existing bias. We need to be very careful about these considerations. The thing that we need to keep in mind is ultimately we as research software engineers, we as researchers are responsible for the work that we submit to our research communities, no matter how that work was generated. So it is on us to uphold research ethics. The LLM is just a piece of software and statistics. It has no ability to make decisions and uphold ethics. That is up to us, the researchers, to do that work. So the top level highlight that I want research software engineers to keep in mind is that while we're seeing attractive looking results from industry software development teams when it comes to incorporating these LLM-based tools and allowing those industry software developers to complete more work, or at least author lines of code faster, we as research software engineers should not consider these LLMs to be magic bullets. They are not going to fix things for us. We still need to be thoughtful. We still need to ensure that we develop high skill in order to ensure that the LLM generated output adequately meets the quality and ethical standards that we want to see in our software. What I would say is really sort of a short and sweet way to emphasize this. Research software engineers who let LLMs code for them are going to have bad code. And I'm using code here as a shorthand for the entire process of software development here, where we need, as research software engineers, to be involved very thoughtfully in the planning of what software we need to develop as we're doing our research. Sure, the large language models can help us in actually generating the lines of code, but we need to be the ones planning what lines of code should be generated, what the actual target behavior needs to be, and we are the ones ultimately responsible for determining if the generated code does meet the research objectives and the quality objectives that we have for our code bases. So we need to ensure that we have good software development skills before we just start using LLMs to generate code for us. Similarly, research software engineers who let these LLMs do research for us are going to violate research ethics. The LLMs are notorious for omitting relevant data in their citations or generating false citations. So we are actually the ones ultimately responsible for the research that we are creating. So if we're using LLMs to generate components of that research, we still need to make sure that we are following correct research ethical practices, disclosing what we're doing, discussing the sources for the ideas that we're building our research upon, and making sure that we're appropriately citing all of the relevant sources. At the end of the day, we're the ones responsible for our work. The LLMs are just software and statistics. They are not capable. These tools are not in any way capable of assuming responsibility for us. We, the research software engineers, are responsible for the content that we submit to our research communities. So hopefully this perspective discussing how the emerging LLM-based software tooling that we're seeing intersects with research software engineering community concerns and research ethics has been interesting. I would really love to see people comment on their thoughts and potentially include more resources or questions. I have generated a document that contains my thoughts and various resources that I have cited as I built this presentation. So I invite comments and discussion there at the URL I have listed here. And I just invite us all to keep these three key takeaways in mind as we look at incorporating these LLM-based tools into research software development. Thank you very much and have a nice day.
Thank you for watching this episode. Please check out the slides on Zenodo linked below and see you next time.